Okay guys, for the second part of this section, I'm going to just focus on three specific example problems of what you're going to be able to do with the tangent. So what we're going to do is find the equation of the line tangent to f of x equals 3x squared plus 4 and goes to the point 1, 7. Now just so you guys can visualize what that looks like, we have our graph here. Y equals 3x squared plus 4. It looks something like that. There's the point 1, 7. And we're going to find the line that goes right through that touches that graph right at that point 1, 7 and is tangent to that. Well, to make a line, for the equation we need two things. We need an m and we need a b. Well, to find the m is the slope. And if you remember, the derivative formula tells us the slope at any given point. We know the point is going to be at 1, 7. So we have to figure out, okay, what is the slope at that point? So we're going to do, okay, the limit is delta x approaches 0 of f of x plus delta x minus f of x all over delta x. So we plug that in and we get, alright, 3x plus delta x squared plus 4 minus 3x squared plus 4 all over delta x. We'll distribute and multiply by 3, so we get 3x squared plus 6x delta x plus 3 delta x squared plus 4 minus 3x squared minus 4 all over delta x. We get the 3x squareds to cancel out. We get the plus 4 and the minus 4 to cancel out. We get 6x delta x plus 3 delta x squared all over delta x. We can factor out a delta x and cancel it out from there and just from 1 from there. And the derivative is going to be 6x plus 3 delta x. And so basically we get f prime of x equals, as the limit goes towards 0, goes away, equals 6x. So now that we know the derivative is 6x, what we can do is take our 1 and plug our x into there. So we know the slope, f prime of 1, is going to be at 6, 1. The slope, f prime of 1, equals 6. So we know this line has a slope of 6. We found the derivative and we plug in the x value. Now what we need to do is find the corresponding y value, and that's pretty easy because we have our m and our x and y from our point. So we're going to take y equals mx plus b, and we're going to take our point 1, 7, so 7 equals 6 times 1 plus b. Pretty simple. B's got to equal 1. So the equation of that line's got to be y equals 6x plus 1. Okay, next we're going to find the equation of the tangent line with a slope of 5 that is tangent to x squared minus x. So we don't know quite exactly where the point is, but we know wherever that point is, it's got to have a slope of 5. So just like before, we're going to find the derivative of x plus delta x minus f of x all over delta x. Alright, so we'll plug in x plus delta x in for both of those. So the equation looks like x plus delta x squared minus x plus delta x minus x squared minus x all over delta x. We'll distribute. We get x squared plus 2x delta x plus delta x squared minus x minus delta x plus minus x squared plus x all over delta x. Now let's see, anything cancels out. We got x squareds cancel out. We have an x cancel out. And so we're left with 2x delta x plus delta x squared minus delta x all over delta x. Now we can factor out the delta x and cancel it out, and we get 2x plus delta x minus 1. And as delta x goes towards 0, f prime of x, our derivative function, equals just 2x minus 1. Alright, so that gives us the equation of all slopes in the graph. Well, we want to find when this slope equals 5. So we need to find that place. Because we already know in our equation our m equals 5, we need to find our b. We need an x and y point to find that. Well, what we're going to do is take our 2x minus 1, this is our equation of a slope, and set that equal to 5, because that's our slope value we're trying to find. So 2x equals 6, x has got to equal 3. So we can plug that in. Okay, now we got to find the y. Now what we have to remember, this y is the y of the function. So we're not going to just plug it into this one or this one. We're going to take x and we're going to plug it into the original function. So f of 3 equals 3 squared minus 3. 3 squared is 9. 9 minus 3 is 6. So we know it goes to 0.36. Okay, now we have our m. Now we have our x and y to find b. We're going to do y equals mx plus b. So y is 6 equals m is 5 times 3 plus b. That gives us 15. Subtract 15. We get negative 9 equals b. So the equation of the line would be y equals 5x minus 9. And you know, we can always go back and graph to check. We could graph this line, and we could graph that, and we could see it intersects at the 0.36. Okay, next, what we're going to do is find the equation of the line, or tangent line, or lines, that is parallel to y, or 3x minus y plus 1 equals 0, and is tangent to x cubed. Well, first, okay, we need a slope, and we need a b, and we probably need a point, xy. Well, we don't know the point, just like before, but we could figure out the slope by getting this equation, get the y by itself. So y would have to equal 3x plus 1. So we know the slope is going to be 3. There's our slope. Now what we are going to have to do to find the b, we're going to have to find the point value, the x and y. We're going to plug it into there. So we got to find the derivative. So we're going to do that limit is what we've done before. So it is going to be x plus delta x cubed minus f of x, which is minus just x cubed, all over delta x. Remember, we are taking the limit as delta x approaches 0. We factor everything out. We get x cubed plus 3x delta x squared plus 3x squared delta x plus delta x cubed minus x cubed all over delta x. We're going to have this x cubed cancel each other out, and we're left with 3x delta x squared plus 3x squared delta x plus delta x cubed all over delta x. Hopefully, while you guys can see what's going to happen, that will go away, that goes away, and this becomes squared. And so we get 3x delta x plus 3x squared plus delta x squared. And as delta x goes to 0, that goes away, that goes away. So f prime of x, our derivative function, is just 3x squared. Alright, now just like the last problem, we need to find the point values. So we're going to take our 3x squared and we're going to set it equal to the slope, which in this problem equals 3. Remember, we figure out the slope equals 3. So now we need to solve, and so that means x is going to have to equal positive and negative 1. So what this means is basically we are going to have two lines that both have a slope of 3 and both are tangent to the graph, which could happen because what this graph is going to look like, here's y equals x cubed. We're going to have one line here and we're going to have one line there. They're both tangent. Alright, so what we do next, now that we have two x's, we're going to have to figure out the 2 points. So one of the points, we're going to take our positive 1, and we're going to plug it back into the original function. Oop, it's right there. So when x is positive 1, we're going to have a point at 1 cubed, which is 1. So we're going to do y equals mx plus b. So we get 1, and we're going to plug in 3 for m, so 1 equals 3 times 1 plus b. B's got to equal, what is that, negative 2. So one of the equations is y equals 3x minus 2. So that's with the positive 1. Now we got to do with the negative 1. So negative 1, we plug negative 1 back into f of x. We get negative 1 as well. And we just rewrite the equation. Negative 1 equals 3 times negative 1 plus b. Multiply by negative 1, add that over, so we get 2 equals b, a positive 2, so our equation is y equals 3x plus 2. So we actually get two equations here. They are both tangent to that line, and they're parallel to that line there. Alright, if you need some help, make sure you ask. Well, you guys should be alright with this. Good luck.